A function is a relation with a special property. It's a relation that maps each and every element of its domain to exactly one element of its codomain. The idea of a function is important to a great deal of mathematics, and it's also important to programming. Let's look at some examples. Here's a simple unary function. Factorial maps from the natural numbers to the positive integers, and factorial of some number n is just the product of the positive integers from 1 to n. So for example, factorial of 4, often written 4 exclamation mark, 4 factorial, is 1, 2, 3, 4, multiplied together to give you 24. Just to make it clear, the boundary case, by definition, 0 factorial is 1. So we can map from the natural numbers that include 0 to the positive integers using this definition. Now let's do it in code. Here's code written in Python. I picked Python, it's easy. I'll show you some examples in a couple of other programming languages in a minute. So here's the Python code in which I define my function. I tell you how to compute it. And if you look at the code, the important thing to notice is that it takes one input, we're calling it n, and it returns one output, we're calling it result. And once you've typed that definition, you can invoke your function. And so you could say something like, well, what's factorial of 4? And it'll come back and say 24. You can say, what's factorial of something bigger? And it'll come back with something even much bigger. The fact that this is a function matters, that it returns a unique value all the time. Why? Because it enables other people to write in their code things like this. If factorial of some number v is less than 100, then do something. That means whoever writes this code has to count on the fact that for any natural number, a value is going to come back, exactly one value is going to come back, and it can be checked. So that's why this fact that it is a function is so important. All right, so now let's look at another example. Square root maps from the positive reals to the positive reals. And so we need to have the square root of 4 be 2. We need not to have the square root of 4 be minus 2, despite the fact that minus 2 times minus 2 is 4. We need to make square root a function. It has to return a unique value. And we did that by saying we will return the positive square root. So here's a case where if we weren't careful, we wouldn't have a function, but now we do. All right, and so we map from the positive reals to the positive reals. And here's another piece of Python code. It takes in one number, returns one number. In case you care, if you want to look at this code, it uses a cool algorithm called Newton's method. But you don't need to know that if you just want to compute square roots. So you can invoke this function. You can say square root of 104, and you get back a number that's a little bit bigger than 10, which is what you'd expect. Okay, sometimes our functions need to take in more than one value. For example, greatest common divisor. The greatest common divisor of two integers, two positive integers, is the largest number that evenly goes into both of them. So the greatest common divisor of 12 and 20 is 4. So now note that we need to take as our domain the positive integers cross the positive integers, and we return a single positive integer. We still take in one value and output one, but the one we take in is now a pair. Okay, and it could be a triple or whatever else. We're not limited. So let's look at the code for that. Here's a piece of Python code that computes greatest common divisor. You can tell its name is GCD Euclid. It uses a technique called Euclid's method, but again, it doesn't matter as long as you trust me that my code is right. I have defined a program that takes in 2 arguments and outputs 1, and you can invoke it. You can say GCD Euclid of 20, 12, and you'll get back, as we just said a minute ago, 4, but you can also say GCD Euclid of, I don't know, some bigger numbers where the answer is not immediately obvious, and it'll come back and say, in this case, 6. Okay, let's look at another example of what we'll call a binary function. This time I'm going to switch programming languages, so you can see this isn't a property just of Python. So least common multiple is similar, although this time what we're saying is give me 2 positive integers and tell me the positive integer that's the smallest one that is divisible by both of the ones that you gave me. So, for example, least common multiple of 12 and 20 is 60. There aren't any integers that are evenly divisible by both 12 and 20 that are smaller than 60. So I take in a pair and I output a single result. I take in an element of z plus cross z plus, and I output an element of z plus. All right, and here's code written in Java. If you look at it, the code just looks different. The syntax is different. But again, I take in two arguments, call them a and b, and I return a single value. I can define how I invoke my function. And so, in fact, I do that here. And if I invoke that, then I get back 46, which is the answer. All right, so the syntax is different, but the concept of what the programming language does for me is the same. I define functions, and I use them. All right, let's look at a really simple example, multiplication. It's another binary function. It takes in two integers and returns another one. Okay, there you go. Let's look at the code. The Python code to define the multiplication function. You're looking at it. You don't have to write anything. It's built in. It's so common that it's built in. So it's there, and you can invoke it. You can say, what's 7873 times 894? And notice that in this case, we actually have a special notation, what we're calling infix notation, in which we have a special symbol defined for multiplication because it's so common. All right, and we get the answer back. What if you don't know how many inputs or how many outputs? Function has to map from one element of its domain to one element of its codomain, and that might not be what you want. So for example, suppose I want to define this function evens. It takes in a set of integers and it returns another set in which I've thrown away all the odd values. So I want evens of this set, 1, 92, 5, 8, 20, to be 92, 8, and 20. How can I do this? Using the notion of a function. And the idea is that I now map from a set of sets to a set of sets. And here's my Python code. You don't have to pay much attention. The idea is that, again, we take in one value. It happens to be a set, and we return one value. It, too, happens to be a set. Okay, so I can invoke it if you want like that and get back the answer that I told you we ought to get for that. Okay, now we can map to things besides numbers and sets of numbers. For example, what if we want to ask a question, a Boolean valued question about something? The values in the codomain are true and false. So let's look at an example of that. So symmetric P is going to take in a relation and map to true or false, just in case it gets true, in case the relation isn't back symmetric, and false otherwise. And just to remind ourselves of what it means to have a symmetric function, a symmetric relation, a relation is symmetric just in case whenever AB is an element of R, so is BA. So we want to check for that property. Now, if I'm going to write code for this, I have to have a way to input the function. I need some data structure. I need some way of representing, the relation that I want to ask about. So we know we need to do that mapping. Let's do it by representing, in this case, the relation as an adjacency matrix. All right, so here's an example. Stare at this for a minute, and we want to know whether the relation that's represented by this matrix is symmetric. And if you stare at it, you'll see that it is. I want to show you how we could use yet another system. MATLAB is a programming environment that does well with matrices, like the one you just saw, so we picked it to do this example. Here's our MATLAB code. It takes in one of those matrices, and it outputs a Boolean that it computes in this way. You don't have to worry about the details. So again, I input one matrix in this case, and I output one Boolean value. So the summary is, programmers would be lost without functions.